Hey everyone! Today we're going to solve a system of equations using the elimination method. Now before I show you the strategy, let's play a little guessing game. Now I'm thinking of two numbers. Let's call them x and y. Now these two numbers, when they add, you get 10. But when you subtract those two numbers from each other, you get 4. So, in other words, the sum of these two numbers add to be 10. But the difference of those two numbers, when you subtract them from each other, you get 4. So, what two numbers am I thinking of? I'll give you some time to think about it. Okay, so let's see if you got it right. The two numbers that I was thinking of was 7 and 3. That's because the sum of 7 and 3 is 10. But the difference of 7 and 3, when you subtract 3 from 7, you get 4. So the solution is 7 and 3. Okay, so let's think of this puzzle a little bit differently. Let's come up with all possible ways for two numbers to add to be 10. So I'm going to organize our two numbers in a neat little table. Okay, so x equals 0 and y equals 10 is a solution because 0 plus 10 is 10. So I'm going to put 0 and 10 into our table. What else do we have? Well, x equals 1 and y equals 9 is also a solution because 1 plus 9 is 10. So 1 comma 9 will also be placed in our neat little table. What else do we have? We can get 2 comma 8 or 3 comma 7 or 4 comma 6 or 5 comma 5. And the list can continue on. In fact, there are infinite possible ways for two numbers to add to 10. So what would happen if I were to graph all of these solutions? If I were to graph all these solutions, you actually get a line. And there you go. Now let's go ahead and do the exact same thing, but this time let's come up with two numbers. When you subtract them, you get 4. Okay, so I'm going to organize this in another table. But this time, I want to come up with two numbers. When you subtract them, you get 4. So for example, 4 and 0 is a solution because x equals 4 minus y equals 0 is 4. So 4 comma 0 is a solution. What else do we have? Well, x equals 5 and y equals 1 is a solution because 5 minus 1 is 4. What else do we have? Well, we can also do 6 comma 2. We can also do 7 comma 3 or 8 comma 4, and the list continues on. And again, there are infinite possible ways for two numbers to subtract to be 4. So what would happen if I were to graph this table? If I were to graph this table, you also get a line. Okay. So now, what is the solution to the system of these two linear equations? In other words, what pair of numbers, when you add them, you get 10, but when you subtract them, you get 4? The answer is 7 and 3. Makes sense because when you observe the two lines, they intersect at the point x equals 7 and y equals 3. That is called the solution to the system of equations. Okay, so now that you kind of have an understanding of what we're trying to do here, there's a lot faster way to solve the system without having to list all the possibilities or even graph the two lines. That strategy is called the elimination method. Now, the whole point of the elimination method is such that when you combine the two equations, one of the variables are eliminated so that you can solve for the other variable much faster. Here's what I mean. When you combine those two equations, something gets eliminated. So what happens when you combine them? Well, we have x plus x, that is 2x. But what happens when you combine the y's? We have positive y combined with negative y. Well, they're opposites of each other, so they are eliminated when you combine. But what about the right side of the equal sign? We have 10 and 4. So when you combine 10 and 4, we get 14. So when you combine these two equations, notice that the y's are eliminated. So we now have a simple equation, 2x equal to 14. So then how do we solve this equation? It's a very simple one-step equation. All you gotta do now is divide both sides by 2. So when you divide both sides by 2 now, we got x equals 7. Okay, so now how do you find the other number, y? Well, we already know that x equals 7. So we can take that number and plug it back into either of these two equations. It actually doesn't matter which one you plug it into, because either way, you'll get the same exact solution for y. So let's go ahead and do that. Let's plug in x equals 7 into the first equation. So when I take that first equation and then plug in x equals 7, what do we have? Well, we now have 7 plus y equal to 10. So then how do you get y? Well, when you subtract 7 from both sides, then we get y equal to 3. Now that was our first example of an elimination method. Okay, so let's go ahead and practice a few problems together. Okay, so here's another example of two equations where we have to use the elimination method to figure out the solution. In other words, we have to figure out what x and y has to be to make both equations true. Well, this one's pretty difficult to do in our heads, just like the other problem we just did. So instead of guessing, we can use the elimination strategy. In other words, if I were to combine these two equations, can I eliminate one of the variables? In fact, yes we can. Because notice, when I combine these two equations, one of these variables do get eliminated. Well, if I combine 10x and negative 2x, or minus 2x, we get 8x. But what happens to the y's? Well, when you combine a negative 3y and a positive 3y, well, they're opposites of each other, so they cancel out. In other words, it combines to be 0. Okay, so then what's on the right side of the equal sign? Well, 18 combined with 6 is 24. And there you go. Now we have a very simple one-step equation. 8x equal to 24. In other words, 8 times something has to equal 24. So what is that something? What does x equal to? Well, if I divide both sides by 8, we get x equals 24 divided by 8, which is 3. So 3 is our solution. But what about y? What can y be? Well, now that we know x equals 3, we can actually plug that back in to one of these two equations to figure out y. For this problem, let's go ahead and plug it into the second equation. So if I plug it into the second equation, knowing that x equals 3, well, if I plug in negative 2 times x equals 3 plus 3y equals 6. Then we just got to solve for y. Well, negative 2 times 3 is negative 6. And then if we continue solving for y, to isolate y, we're going to add 6 both sides. So 3y equals 12. Then to get y isolated, we're going to divide both sides by 3. So what is y equal to? Y is equal to 4. So there you go. We now have a solution, x equals 3 and y equals 4, or the coordinate point 3, 4. And that is a solution to the system of these two linear equations using the elimination strategy. So now let's go ahead and do some more complicated problems. Okay, so here's another example of a system of two linear equations. So let's see if the elimination strategy works. If I were to combine these two equations, let's see if one of the variables are eliminated. Well, if I combine 5x and x, we get 6x. And if we combined negative 2y with a positive 1y, well, there's more negatives than positives, so we have negative 1y left over. But on the right side, we got negative 50 combined with negative 3. That's a grand total of negative 53. However, the elimination strategy did not work because neither of the two variables are eliminated. So this is a case where the elimination strategy failed. However, we can actually manipulate or change one of these two equations such that when you combine them, one of the variables do get eliminated. Here's what I mean. If this right here is negative 2y, I kind of wish that this right here is a positive 2y. Because if I combined a negative 2y and a positive 2y, then they are eliminated when you combine those two equations. But we can't just slap a 2 next to the y. So instead, what we can do is we can multiply the entire equation, the second equation, by the constant 2. Now, multiplying by 2 or any constant to the entire equation actually doesn't change the overall line. It will just look different. So here's what I mean. So when you combine those two equations, this is what we get. This is 5x minus 2y equal to negative 50. But the bottom equation, we now have 2 times x, which is 2x, 2 times y, which is positive 2y, and then 2 times negative 3, that is negative 6. Now, multiplying by everything by the same constant is still okay, because that actually doesn't change the slope or the y-intercept of that same line. It just looks different. So let's go ahead and see what happens when you combine those two equations. When you combine those two equations, let's see what we get. 5x plus 2x is 7x. But negative 2y combined with positive 2y, well, that is now eliminated because they're opposite of each other. But what about on the right side? Well, negative 50 combined with negative 6 is negative 56. And there you go. We now have a simple one-step equation. So when we divide both sides by 7 now, we get x equals negative 8. Because negative 56 divided by 7 is negative 8. Alright, so now that we have x equals negative 8, we can now plug it back into any of these two equations to figure out y. Let's go ahead and do that into the second equation because it just looks simpler. So if I plug in negative 8 into x plus y equals negative 3, let's go ahead and solve for y. Well, to isolate y, we're going to do the opposite of negative 8, which is positive 8, or add 8. Then we have y equals to negative 3 plus 8, which is 5. So there you go. So what is our solution? Our solution then is x equals negative 8 and y equal to 5. And there you go. So now let's go ahead and do some more problems where you do have to multiply an equation by a constant to eliminate. Okay, so now here's another example of a system of two linear equations. Let's see what would happen if I were to combine them immediately. Well, if I were to combine them, x and 4x combines to be 5x, and 5y combined with negative 3y, well, that's positive 2y. So none of the variables are eliminated, so the strategy doesn't work, at least at this point. So what I could do is try to multiply one of these equations by a constant such that when I combine them, one of the variables do get eliminated. Okay, in this example, let's go ahead and try to eliminate the x's. Well, if this has a coefficient of 4 for x, then I kind of wish that this equation right here also has a 4x, but instead a negative 4x. Because if this was a negative 4x and this is a positive 4x, when you combine them, they do cancel out. So here's what I'm going to do. I'm going to multiply the first equation entirely by negative 4. So I multiply negative 4 by x, which gives us negative 4x. Then negative 4 times 5y is negative 20y. Then negative 4 times negative 8, a double negative, gives us a positive 32. And there we go. The second equation, we didn't do anything to it, so we're just going to copy it to the side. And there we have it. So let's see if the elimination strategy works at this point. If I were to combine these two equations, let's see, negative 4x and positive 4x do get eliminated because they're opposites of each other. So now what will happen if I were to combine the y's? Negative 20y combined with negative 3y is a negative 23y. Then positive 32 combined with negative 9, well, when you combine them, we get positive 23. So then how do we isolate y? Well, we just divide both sides by a negative 23. That way, negative 23 divided by negative 23 becomes a double negative positive 1y. Now when we divide 23, a positive 23 divided by negative 23, well, there's only one negative, so it's negative 1. And there you go. So again, we know y is negative 1, but then what about x? How do we find x after this point? All we gotta do now is plug this back in to not just one, but either of those two equations. So let's go ahead and plug this into the very first equation right there. So x plus 5 times the y, which is negative 1, equals negative 8. And let's go ahead and solve for x. So x and then 5 times negative 1 is negative 5, so minus 5 equals negative 8. So now to isolate x, I'm just going to get rid of a negative 5. Opposite of minus 5 is to add 5 both sides. So then we have x is equal to negative 8 plus 5, which is negative 3. And there you go. So now we have a solution, x equals negative 3, and y is equal to negative 1. And that is a solution to both of these linear equations. Let's go ahead and try another example. Okay, so now here's another example of a system of two linear equations, and we're going to use the elimination method. But notice again, when we combine those two equations right now, neither x and y is eliminated. Okay, so what can we do? Now this one's a little bit tricky. Instead of multiplying just one equation by a constant, I'm actually going to multiply both equations by something. Let's go ahead and try to eliminate the y's here. Let's multiply the top equation by 4. Now the reason why I want to choose 4 is because I want 4 times 3y, which is 12y. You'll see why in a second. I'm also going to do the bottom equation by negative 3. Now the reason why I chose negative 3 is because I kind of want this term, negative 3 times 4y, that gives us negative 12y. Now, do you kind of see why I chose 4 and negative 3? Let's see what happens when you multiply them out. So 4 times 3x, well, that's 12x. Then 4 times 3y, that gives us 12y. Then 4 times 9, that gives us 36. Now what happens to the bottom equation? Well, negative 3 times 5x, well, that's negative 15x. Then negative 3 times 4y, that gives us negative 12y. And then we got negative 3 times 10, that gives us negative 30. Now, notice we have positive 12y and negative 12y. I wanted that to happen because if I were to combine them, they're eliminated. So let's go ahead and take a look at the original equations here. So basically, when I was choosing these two numbers, I was basically thinking of a common multiple of 3 and 4. A common multiple of 3 and 4 was 12. So I decided to multiply the top equation by 4 because 4 times 3 gives us that 12. But I wanted to multiply the bottom equation by negative 3 because negative 3 times 4 gives us negative 12. By the way, notice I chose negative because I don't want two positive 12y's. I want one of them to be 12y and the other one to be a negative 12y. Alright, so let's go ahead and combine. 12x combined with negative 15x, well, that gives us negative 3x. But what happens if I were to combine the y's? When you combine the y's, they're eliminated. Alright, so what happens when you combine the right side? Well, 30x minus 30, that's just 6. And there you go. So all we gotta do now is divide both sides by negative 3, so we get x equals negative 2. Because 6 divided by negative 3 is negative 2. So again, how do you find the other pair, the y? We can just plug it back in. And again, it doesn't matter which one you plug it into, you get the same solution either way. Let's go ahead and plug this one into the second equation. So we have x is negative 2. So 5 times negative 2 plus 4y has to equal 10. 5 times negative 2 though is negative 10. So now let's go ahead and isolate the variable y. To get y by itself, I'm going to go ahead and eliminate the negative 10 by adding 10 both sides. That gives us 4y equal to 20. Then to get y by itself, I'm going to go ahead and divide by 4 on both sides. That way, 4 divided by 4 gives us 1y. So 20 divided by 4 is 5. So our final solution is x equals negative 2 and y equal to 5. And there you go.